Myself, Dr. G. Venkat Subbareddy, Associate Professor, Electrical and Electronics Engineering Department. Our subject is Control System Engineering. In this Control System Engineering, today class we discuss about what are the control system and what are the various components in control system. What are the different types of control system? What are the different types of control systems? Control system is definition. Control system is a combination of elements or arranged in a planned manner where each element causes an effect to produce the desired output. The cause and effect relation is linear, then the system is said to be linear control system. In a control system, one is a input signal, another one is a output signal. Input signal is nothing but the stimulator excitation is applied to the control system from external source in order to produce the output. Output is called output. That is nothing but apply the input signal. Output is nothing but actual response is obtained from a system is called output. One input and one output. The Laplace transform of output to input is nothing but a transfer function. System. System is an arrangement or a combination of different physical components connected in a planned manner to form an entire unit to attain certain objective. That is nothing but a system. A system has input signal and output signal. For example a fan. Fan has a input signal and output signal is there. Then fan is nothing but a system. This example of system is nothing but one is ceiling fan. Cannot a system. A fan without blades is cannot said to be a system. A fan without blade to be a system, but it cannot produce a desired or proper output. Input signal is 230 volts 50 Hz AC supply, but the output is not no airflow, no proper or desired output, then it cannot be said to be a system. It can be said to be a system, but it cannot produce a desired or proper output. A fan with blades with regulator can be said to be system because it provide a proper output, that is airflow. Fan with regulator and blades that can be set to the desired output, then that can be said to be a system. But it cannot be a control system because it cannot provide the desired output, that is a controlled airflow without regulator. A fan blades without regulator can be a system, but it cannot provide a proper output, that is airflow. Provide output. But it cannot be a control system because it cannot provide the desired output, that is nothing but a controlled airflow. Input signal is nothing but 230 volts and AC supply. The output is nothing but a airflow. That is nothing but a proper output. A fan with blades with regulator can be a control system because it provided desired output. That is nothing but input signal is nothing but 230 volts and AC supply. Controlled element is nothing but a regulator. Then output is nothing but a controlled flow of desired output. At a control system is nothing but a input signal and output signal. But another one is a controlled action. That is nothing but said to be a control system. Control. It means to regulate the desired, it means regulate direct or command to the system. So that is a desired objective is attained, that is nothing but a control. A combination of system plus control, that is known as a control system. Then we define as that a control system is a combination of elements or arranged in a planned manner. Each element causes an effect to produce the desired output. Cause and effect relation is a linear, the system is said to be a linear control system. Control system is nothing but a system plus control is known as a control system. Input signal, control system then produces the output signal. It is an element of a different physical elements connected in a planned manner as to regulate the input to achieve the desired output. That is nothing but a control system. Differences between system and control. A system is a proper output may or may not be desired, but control system is a desired output. This is the difference between the system and control system. In case of system, may or may not be desired output, but in case of a control system, it is a desired output to get the desired output. Classification of control systems. The control systems are classified into two types. One is nothing but a open loop system, the another nothing but a closed loop system. That is also called as a automatic control system or a feedback control system. And control systems are classified into two types. One is nothing but a open loop system, the another is nothing but a closed loop systems. Definition of a open loop system. Open loop system is nothing but the output cannot be feedback to the input. That is nothing but only input is given to the system, then produces the output. A system in which control action is totally independent of the output, the system is called an open loop system. Only we give the input signal through the control process, then we get the output signal. Output cannot feedback to the input. Such type of systems is known as a open loop control systems. Open loop control system only input applied the signal through a control process, then get to the desired output. That is the simple block diagram of a control system. This is nothing but a simple block diagram of a control system, open loop control system. For example, electric hand dryer is a open loop control system because hot air is output comes out as long as you keep your hand under the machine, irrespective of how much of your hand is dried. This is nothing but only you give the input signal, that is nothing but to get the output. The another example of a open loop control system, automatic washing machine. The machine is runs according to the preset time irrespective of washing is completed or not. That is nothing but another examples of open loop system. One more example, bread tester. This machine runs as per the adjusted time irrespective of testing is completed or not. This is nothing but one more example of open loop control system. This is automatic tea, coffee, vending machine. This is also nothing but another example of open loop control system. Closed loop control system. In case of closed loop control system, a part of the output can be feedback to the input by using a summing point. That is nothing but a closed loop system. A system with a control action is somewhat dependent on the output is called closed loop control system. Reference input signal and output signal control action process. Then feedback element is output. A part of the output is feedback to the input through the summing point. This type of control system is known as a closed loop control system. Input signal is a reference input. Output is controlled action. C of t is taken to the feedback to the input signal by making a summing point. That is nothing but R of t minus C of t is nothing but a error signal which produce the error signal which is through a control process. Then we get to the controlled output. Okay, up to control output, this can be continuously processed. That is nothing but a closed loop system. The difference between open loop and closed loop system. Then in case of open loop system, the input signal is through a control action, then produce the output. But in case of closed loop system, a part of the output is feedback to the input. That is the differences between the block diagrams of a open loop and closed loop systems. It is nothing but a closed loop system. The components of a closed loop system, the input signal and control action, actuator, vehicle mechanism, the control process, then we get to the actual. This is one of the closed loop system. A sensor is feedback to the input signal. Desired speed, amplifier, armature, load and actual speed and tachometer. This is nothing but a block diagrams of a closed loop control systems. Automatic electric iron. That is nothing but example of a closed loop control system. Heating elements are controlled by the output temperature of the iron. This is nothing but the one example of a closed loop control system. That is nothing but automatic electronic iron. That is nothing but one of the closed loop control systems. The closed loop control refrigerator or freeze is nothing but depending upon the temperature control is also the example of a closed loop control system. It is nothing but home heating control system is also one of the example of a closed loop control system. The reference input VR minus VT is greater than 0, that is a cold condition, open the valve, and VR minus VT is less than 0, that is a hot condition, close the valve. It is nothing but depending upon the part of the output, then they given to the control actions. That is nothing but another example of a closed loop control system is home heating control system. Advantages of open loop system. The open loop system is nothing but a simple in construction. Construction is very simple. Design as a components required very less. Then economical, generally stable systems. These open loop systems are generally stable. Disadvantages of open loop system ఏమంటే the systems are they are inaccurate, they are unreliable. Any changes in output due to the external disturbances cannot be corrected automatically, affected by the noise. This is the one disadvantages of a open loop control systems. This is inaccurate, unreliable. Any changes in the output due to the external disturbances cannot be corrected automatically, and another disadvantage is affected by a noise signal. The advantages of a closed loop system: closed loop control systems are more accurate even the presence of non-linearities. Closed loop systems are more accurate as compared to the open loop control systems when the presence of non-linearity. High accurate, as any error arising is corrected due to the presence of feedback or sensor signal. That is nothing but a feedback signal. Any highly accurate. Facilities of automation: the sensitivity of the system may be small to make the system is more stable condition. The system is less affected by noise due to the external disturbances. This is all the advantages of a closed loop control systems. Disadvantages of major disadvantages: they are costlier. The cost of the closed loop system is very high as compared to the open loop system. They are complicated to design. To design the closed loop control system is complicated. Stability is the major problem and more care is needed to design a stable closed loop system. Stability is more in case of open loop system. Stability is the major problem in closed loop control system. The overall gain is reduced due to the presence of feedback. The overall gain is reduces due to the presence of feedback. These are the comparison between the open loop and closed loop system. The open loop systems are simple and economical, then the closed loop systems are complex and costlier. This is one comparison. The another comparison is they consume less power. In case of closed loop control system, they consume more power. The open loop control systems are easier to connect because of it requires less number of components. Then closed loop control systems are not easy to construct because it requires more number of components. The number of components is more in case of a closed loop control system as compared to the open loop control system. The open loop systems are inaccurate and unreliable, but the closed loop control systems are accurate and more reliable. Closed loop control systems are more reliable because they get the desired output due to the presence of feedback. Open loop systems are generally stable. Stability in open loop system is more, and care should be taken for design in case of a closed loop control systems. Feedback element is absent. In case of open loop system, the feedback element or sensor which is present in a closed loop system. The changes in the output due to the external disturbances are not corrected automatically, as so they are more sensitive to noise and other disturbances. In case of closed loop system, the changes in our output due to the external disturbances are corrected by automatically, so they are less sensitive to noise and other disturbances. These are the differences between the open loop and closed loop systems. The differences are: open loop systems are simple and economical, closed loop system is a complex and costlier. Open loop systems is consume less power. In case of closed loop system is more power. Open loop system is easy to construct. Closed loop system is the closed loop system required more components that is not easy to construct. The open loop systems are inaccurate and unreliable, but a closed loop system is more reliable as compared to the open loop system. And open loop system is generally stable. Stability condition is more in case of open loop system, and care should be taken while designing the closed loop system. Feedback elements are present, not absent. In case of open loop system, feedback elements are present in a closed loop system. The changes in output due to the external disturbance is not corrected automatically because there is no feedback in case of open loop control system, so they are more sensitive to noise and other disturbances. But in case of closed loop system, the changes in the output due to the external disturbances are corrected by automatically, so they are less sensitive on noise to the other disturbances. These are the major differences between the open loop and closed loop system. These are very important point of view. The differences between open loop and closed loop systems. The component of a closed loop system. What are the components? Main components are present in a closed loop system. One is nothing but a reference input signal that can be represented as a RFT. Then amplifier or controller and equator. Then plant. Plant is a control main plant. Then output is nothing but a control output that can be feedback to the feedback system or sensor in the feedback. That is a forward path. The key bottom is nothing but a feedback. These are the main components: amplifier, controller, actuator, plant. This is the forward path components. In feedback components, the feedback systems are sensor. Then output is C of t. C of t is taken from the feedback. Then R of t minus C of t is nothing but error signal, which can be produced as the error signal, the difference between the reference input, the output coming from the controlled output. This error is applied to the amplifier. It can be converted into required form of the energy that can be acceptable by the plant. Then after the plant, the output is obtained. Then this process is continue until the desired output is obtained through the control system. These are the main components in case of a control, in case of closed loop control systems. Then the components in the first one is the error detector, that is the difference between the input signal and output signal. Compare the reference input and actual output obtained from the generate error signal. The difference between the input and feedback signal, that is nothing but a error detector, E of t. Amplifier amplifies the error signal. Controller is control the amplifier error signal, and actuator is convert the control signal to the accepted form of the plant, and feedback or sensor signal measure the actual obtain the output signal. Plant, it is the system in which the control action is required. These are the main components that can be used in case of a closed loop control system. That is nothing but open loop control system: input signal, controller, plant, output. In case of a closed loop control system, reference input, the error detector, controller, activator, plant. Then sensor is nothing but a feedback system. These are the two black diagrams of a open loop and closed loop systems. Transfer function. Then after completion of open loop and closed loop, this is one part of the our control system. The second one is a transfer function. Transfer function is nothing but the ratio of the Laplace transform of output to the Laplace transform of the input. That is nothing but C of s divided by R of s is defined as a transfer function while initial conditions are assumed to be 0. That is nothing but the relation between input and output of a system is given by a transfer function. The relationship between the input and output of a system is given by a transfer function. Definition ఏ విధంగా అంటే the ratio of Laplace transform of the output to the Laplace transform of the input under the assumptions of zero initial conditions is a transfer function. That is nothing but a definition of the transfer function. The transfer function of a open loop control system, R of t is nothing but input signal, the system is nothing but a g of t, output is g of t. Then taking the Laplace transform, R of t becomes R of s, system g of t becomes to g of s, the output c of s becomes C of s. Then C of s divided by R of s is equal to G of s, that is nothing but a transfer function. G of s is equal to Laplace transform output to the Laplace transform input, that can be defined as a G of s, that is nothing but a transfer function. T of s or G of s we can define as, that is nothing but a transfer function of a given system. The transfer function of a closed loop system is, in case of negative feedback system, the transfer function is G of s divided by 1 plus G of s into H of s. G of s is nothing but a forward path transfer function. H of s is nothing but a feedback transfer function. Next, B of s is nothing but output signal. E of s is the error signal. B of s, R of s minus B of s is equal to error signal. E of s into G of s is equal to C of. We derive the expressions for the transfer function of a given closed loop system. Then finally, you get C of s is equal to, transfer function is equal to C of s divided by R of s is equal to G of s divided by 1 plus G of s into H of s. This is some derivation part to get the output signal. A green color shows that yellow color is known as a total transfer function of a closed loop control systems. First, error signal is obtained. Error is nothing but the reference input signal minus output C of s into G of s. B of s is nothing but C of s into H of s. B of s nothing but C of s into H of s. Next, G of s is equal to C of s divided by E of s. E of s is nothing but error signal. Substituting this and simplify this again, we get final overall the transfer function of a closed loop control system. Nothing but G of s divided by 1 plus G of s into H of s. This is nothing but a negative feedback. In case of negative feedback, in the denominator plus sign. In case of positive feedback, in the denominator is minus sign. In case of negative feedback control system, then the transfer function is nothing but C of s divided by R of s, that is but G of s divided by 1 plus G of s into H of s. That is nothing but a transfer function of a given closed loop control systems. Transfer function of electrical element. How to calculate the transfer function of given electrical systems? Then find out the transfer function. Already defined that transfer function is nothing but this is a Laplace transform of output to the Laplace transform of input. Element, what is the meaning of element? Element is nothing but a physical objective which can be seen and touch. That is in the RLC nothing but elements in electrical system. For example of examples of elements, resistance, inductance and capacitance. Some more physically elements are wood and iron. Variables, the objective which cannot be seen and touched. This is nothing but objectives. Elements and variables. Variables is nothing but a force, voltage, current and power. These are the some examples of a variables. Elements is nothing but it can be seen and touched, and variables it cannot be seen and touched. That can be defined as a variables. Electrical system. A group of elements or variables connected together in a planned manner, it forms a circuit. That is nothing but a electrical system. Example, series circuit, parallel circuit or series and parallel circuit both. This is nothing but a electrical systems. A group of elements and variables connected together in a planned manner to form a circuit, that is nothing but a electrical system. The resistor, how to find out the resistor? What is the resistor? V of t is equal to I into R, then taking the Laplace transform, V of s is equal to I of s into R. The resistor is nothing but any element which can be a bilateral element. The resistor are the time and frequency invariant. Therefore, they transform the resistance is same, the resistance of the resistor. The Laplace transform resistor is also R. Then voltage across the resistor is equal to V of t is equal to R into I of t. Taking the Laplace transform, V of s is equal to I of s into R. That is nothing but a Laplace transform of pure resistor. In case of inductance, in case of capacitor, current flowing through the capacitor I of t is equal to C into di of by dt, and voltage across the capacitor 1 by C into integral of I dt. Taking the Laplace transform across the capacitor, V of s is equal to 1 by Cs into I of s. That is nothing but a, in case of whenever the present capacitor is present in the circuit, then the Laplace transform is nothing but 1 by Cs in case of capacitor. Then voltage across the capacitor is equal to V of s is equal to 1 by C of s into I of s. That is nothing but voltage across the capacitor. Capacitor. Then find out the Laplace transform is 1 by S in case of capacitor. Then inductor. Voltage across the inductor, V of t is equal to L into di by dt. Then taking the Laplace transform, V of t becomes V of s, L into di by dt into L into s into I of s, then V of s divided by I of s, that is equal to L into s. When inductor is present, then the impedance of the inductance is nothing but L into s, the impedance of the capacitor is nothing but 1 by Cs in case of Laplace transform. The only resistance is R. Therefore, the Laplace transform of the inductance is nothing but S into L. The problem for determination of the transfer function from electrical system, any system, electrical system or mechanical system, first of all to find out the Laplace transform and the ratio of the Laplace transform of output to the Laplace transform of input is nothing but a transfer. Procedure to determine the Laplace transform of electrical system. Problems to determine the transfer function of electrical system. How to solve the problems in case of electrical system to find out the transfer function of given electrical system. Some simple procedure how to find out the transfer function of given electrical system. The first for given electrical circuit, identify the elements or variables. Or else in the elements, voltage, current, power, energy like that are variables of the given system. Form the list of variable, identify assuming the input variables and output. What are the input of the signals and what are the output of the signals for electrical systems. And after that, after finding the variables and elements, then write the differential equation using Kirchhoff voltage law or Kirchhoff current law or mesh analysis or nodal analysis. Apply the Laplace transform, rearranging the terms to get the ratio of the Laplace transform output variable to the Laplace transform the input variable, then we get the transfer function of given electrical system. These are the main procedure. This is the main procedure to determine the transfer function of given electrical system. First of all, identify the variables or elements. Then after that, to develop the equations by using the KCL and KVL, then find out the Laplace transform, then find the total transfer function, what is the output and what is the output, taking the Laplace transform of output to the Laplace transform of input, then we get the transfer function of given electrical systems. One example, a simple example, how to find out the transfer function V naught of S divided by VI of. To find the transfer function V naught of S, we want simple RC circuit. In the above circuit, V naught is nothing but output signal, VI of T is nothing but input signal. Output voltage to the input signal. Elements are resistor or capacitor. The elements are two in this resistor and capacitor. To apply the Kirchhoff mesh analysis, then R into I of t plus 1 by C into integral of I of t into dt is nothing but V of t. Then taking the Laplace transform, R plus 1 by Cs into I of s is equal to V of s. That is the one equation. The another output equation, V naught of s is equal to 1 by Cs into I of s. Then divide by two equations, then we get the transfer. Assuming the KVL in the loop, V of t is equal to R into I of t plus 1 by C into integral I of t, then taking the Laplace transform, R into I of s 1 by C into I of s, then that is the first equation to apply the input loop. The second, voltage across the capacitor is nothing but V naught of t. V naught of t is equal to 1 by C into integral of I into dt, taking the Laplace transform of output V naught of s is equal to 1 by S into I of s, then that is I of s is equal to S into V naught of s. Then substituting the equation 2 in equation 1, then finally Vi of s is equal to V naught of s, Sc into R plus 1 plus Sc. Then the transfer function, finally we get the transfer function 1 divided by Rc into S plus 1. S into Rc is nothing but a transfer function, Vi of s is nothing but input signal, V naught of s is nothing but output signal. There is nothing but a black diagram of a given electrical system. Then the output is equal to V naught of s, input is Vi of s, V naught of s divided by Vi of s is nothing but a transfer function that can be defined 1 plus s into Cr plus 1. Or C into S plus 1. That is nothing but a simple example to find out the transfer function of given electrical system. That is one example. Then another example is, then another example, inductance is added in series with that circuit. Then the same procedure is applicable here also. Then Vi of t is nothing but input signal, V of t is nothing but output signal. By applying the KVL for input loop, then we get the Vi of s is equal to R plus SL into 1 plus SC into I of s. Then applying the voltage across the capacitor is nothing but output signal, V naught of s is equal to 1 by SC by I of s. Then ratio of equation 2 to equation 1, the ratio of equation 2 to equation 1, then we get the transfer function V naught of s by V of s, that is equal to 1 by S square into LC plus S into CR plus 1. This procedure will be same. Then applying the loop of input loop one equation, applying the KVL, then out voltage across the capacitor is nothing but V naught of s. Taking the Laplace transform, then apply the ratio of output Laplace transform of output to the Laplace transform of input, then we get the total transfer function of given electrical network. This is another example of to find out the transfer function of a electrical signal. Mechanical signal. Mechanical systems are two types. One is nothing but mechanically translator motion, mechanically rotational systems. Then transfer function of the mechanical systems also find out the similar way. Then these are two types of mechanical system. One is a translatory motion, another one is a rotational motion. It is the study of the motion of the physical body or objective of elements, elevator, plumbing, ventilating, escalator and automobiles. It is not even a mechanical system. These are classified two types. The motion of the body through the straight line is known as a translatory systems. The motion of the body around a around a fixed axis is known as a mechanical rotational system. These are two types: mechanical translatory systems and mechanical rotational. The motion of a physical body along a straight line is known as a translatory system. These are the translator. The motion of the physical body around a fixed axis is nothing but a mechanical rotational systems is nothing but this is a mechanical rotation. The elements mechanical translatory system, the elements are mass, damper element and spring constant. The variables are force and displacement. Mechanical translatory systems, there are three elements. One is a mass, రెండోది is a dashing element and మూడోది is spring constant. In case of variables are force and displacement. Then in case of mass, then output force is equal to, according to Newton's law, m into d square x by dt square. F is equal to m into a is nothing but acceleration, dx by dt is nothing but a velocity, d square x by dt square is nothing but a acceleration. Force is equal to mass into acceleration, that is nothing but a force. The weight of the mechanical systems is represented by the element mass. One is a mass, the second one is a damper element or dashpot. The friction exists in a mechanical system is represented by the element, that is a dashpot or damping element. The another one is nothing but a spring constant. The elastic deformation in the body represented by the element is called K, that is nothing but a spring constant. These are the three elements in case of mechanical translatory system. The variables are force and displacement. These are the two variables in mechanical translatory motion. Mechanical rotational motions, there are three elements: inertia constant, damper element or dashpot, spring constant. Only difference is nothing but in case of mechanical rotational system, in case of mass, it is the inertia, replacement of inertia. The variables are torque and angular displacement in radians. These are the variables. The weight of a physical body represented by electrical mass is known as a inertia. The friction exists a physical body represented by the dashpot or dashing element, that is represented by a B. The elastic deformation of the physical body represented by the element is called spring constant. Inertia, damper element and spring constant, three are the elements in case of rotational system. Variables here is torque and angular displacement. In case of mechanical system, mass, damper element and spring are element translatory motion, force and displacement. In case of rotational motion, torque and angular displacement. That is the difference between the mechanical translatory motion and mechanical rotational systems. These are the equations for force. Then mass is present. F is equal to, according to the Newton's second law, force is equal to mass into acceleration, m into d square x by dt square, that is m into dv by dx. Then that is nothing but a mechanical system. And damping element is present in mechanical system. F is equal to b into dx by dt, that is equal to b into v, that is nothing but a damper element. And spring constant, F is equal to k into x, k into integral of vt, that is nothing but a three elements: force, damper element and spring constant. Electrical systems, equivalent electrical systems, that is nothing but, in case of inductance is present, then V is equal to L into di by dt. Akkada force is equal to m into dv by dt. In case of electrical system, voltage across the inductor is nothing but E is equal to L into di by dt. In case of damper element, the resistance, E is equal to V into IR, I into R. F is equal to B into V, E is equal to R into I. In case of spring constant, then capacitor, voltage across the capacitor V is equal to 1 by C into integral of I dt, E is equal to 1 by C into integral of I dt. It is the analogy circuit. Mechanical translatory motion and electrical system, analogy circuit. These are the analogies. In case of rotational system, then J torque is equal to J into d square theta by dt square, J into d omega by dt. In case of inductance, E is equal to L into di by dt. The comparison because the mechanical rotational system with electrical systems. Torque is equal to B into d theta by dt, B into omega. In case of electrical system, the voltage across the resistor is equal to V, V is equal to R into I. In case of spring constant, torque is equal to K into theta. In case of voltage across the capacitor, 1 by C into integral of I dt is equal to 1 by C integral of I dt. The physical procedure for determine the transfer function of a mechanical systems. Displacement is x as a nodes. These are the simple procedure for find out the Laplace, find out the transfer function of a mechanical systems, similar as that of a electrical system. Assume the displacement x as a nodes. Draw the free body diagrams. This is a procedure. Write the required differential equation at each node. Apply the Laplace transform. Rearrange in terms rearranging the terms in terms of ratio of Laplace transform of output variable to Laplace transform of input variable, which is known as a transfer function. Okay, this is the procedure for find out the transfer function of a mechanical system. First of all, assume the displacement as a nodes x. Then draw the free body diagram. Write the required differential equation at each node. write a required differential equations at each node and apply the Laplace transform, then rearranging the terms in terms of ratio of Laplace transform of output variable to the Laplace transform of input variable, which is known as a transfer function. This is a procedure to find out the transfer function of a mechanical systems. A simple equation, a simple system which consists of a mass, spring and damper element, then find out the transfer function f of s by x of s. X of s divided by s of s is the transfer function. To find out the displacement to the force, Laplace transform of x of s divided by f of s, that is nothing but a transfer function. This is a simple system. Then assume x nodes, x as a node, assume x as a node, draw the free body diagram at x, write a differential equation at x, apply the Laplace transform. Then rearranging the terms to get the ratio of Laplace transform of output to the Laplace transform of input, then we get the transfer function in mechanical translatory motion. Mechanical rotational motion, that is nothing but the elements are J, inertia constant, and K is nothing but a spring constant, B is a damper element. Because we assume that the difference in nothing but displacement x, you assume theta is as a node. Find the transfer function theta of s divided by t of s is a mechanical system, that is nothing but a transfer function of a mechanical rotational system. Draw a free body diagram at theta, write the differential equation at theta, apply the Laplace transform, rearranging the terms to get the ratio of Laplace transform of output to the Laplace transform input, then we get the transfer function of the mechanical rotational systems. Analogy circuit. There are two types of analogy circuit: force voltage analogy, force current analogy in case of mechanical translatory motion, torque voltage analogy and torque current analogy in case of mechanical rotational system. A system becomes analogous or equivalent as long as differential equation governing the system are identified form. The electrical analogy of any other kind of the system if the great importance, since it is easier to solve analyzing the electrical modes of the circuit. There are two types of analogy circuit: force voltage analogy and force current analogy. Similar to the rotational motions, torque voltage analogy circuit and torque current analogy circuits. Mechanical translatory motion, general equation for force. In case of mechanical translatory system, it consists of a mass, damper element and spring constant. Then x is a variable and force is nothing but output signal. F of s input signal. F of s is equal to the differential equation related to the mechanical translatory motion. F is equal to m into d square x by dt square plus b into dx by dt plus k into x. In case of mechanical rotational system, J is nothing but inertia constant, K is nothing but a spring constant, B is nothing but damper element. The torque equation for this combination, torque is equal to J into d square theta by dt square plus B into d theta by dt plus K into theta. That is nothing but mechanical rotational system. Electrical system, compare analogy voltage analogy circuit, then connected the three elements resistor, inductor and capacitor, which is connected in series, then voltage source is applied across the inductor, across this combination RLC combination, then voltage across these elements V is equal to L into di by dt plus I into R plus 1 by C into integral of I dt. Because three elements are connected in series, then voltage is applied across that element. Taking with respect to I is equal to dq by dt, the rate of change of q is equal to the current charge. The dq by dt is equal to I, then V is equal to L into d square q by dt square plus R into dq by dt plus 1 by C into q. Then compare these three equations, then what is the analogy circuit? The first one is a mechanical translatory system, the another one is the electrical system with the voltage source. Then compare first one and third one. Then we get force voltage analogy in case of translatory motion. Then compare the second and third, we get the force voltage analogy in case of rotational system. Then force is equivalent in rotational system is torque, in case of electrical system is voltage. The mass equivalent is inertia, then in case of electrical system is inductance. The viscous friction coefficient B in case of translatory motion, same as that of a rotational motion, but R equivalent element is nothing but R. The equivalent element B equivalent element in case of electrical system is R, and K is nothing but a spring constant in case of mechanical translatory motion and mechanical rotational motion that can be equivalent in the reciprocal of capacitance. And displacement X is nothing but charge in Q in case of electrical system. Compare these three equations, then we get force voltage analogy circuit or torque voltage analogy circuit. The elements are force equivalent to translatory motion, torque is nothing but rotational motion, voltage in electrical circuit, mass equivalent to translatory motion, inertia is nothing but a rotational motion, inductance, and a damper element B in case of translatory motion, damper element is same as that of a rotational motion. That equivalent electrical is nothing but the resistance. The spring constant is equivalent in electrical is 1 by C, that is also same as that of a rotational motion. The displacement X is equal to displacement theta, ikkada charge is Q, the voltage is V, velocity, angular velocity omega, the current is I. These are the analogy circuit, translatory motion, rotational motion and electrical system, that is the force voltage analogy or torque voltage analogy of mechanical system, mechanical rotational system and electrical voltage systems. These are the analogy circuits. Force current analogy circuits. The first two are same in case of mechanical translatory system and mechanical rotational system. F is equal to m into d square x by dt square plus b into dx by dt plus k into x is nothing but mechanical translatory system. Torque is equal to j into d square theta by dt square plus b into d theta by dt plus k into theta is nothing but mechanical rotational system. Equivalent electrical system is nothing but I is equal to c into d square pi by dt square plus 1 by r into d pi by dt plus 1 by L into pi. Here to apply the Kirchhoff current law in case of electrical circuit, the three passive elements which is connected in parallel, then apply the current source across this parallel combination, then I is equal to C into dV by dt, V by R is nothing but a current flowing through the inductor, 1 by L into integral of V dt is nothing but a current flowing through the resistor. Then the current entering into the junction is equal to current leaving the junction, then equation is the Kirchhoff nodal equation is I is equal to C into dV by dt, V by R plus 1 by L into V integral of V into di. Then voltage V is equal to d pi. The rate of change of flux is nothing but a voltage. Then substitute instead of V d pi by dt, I is equal to C into d square pi by dt square, 1 by R into d pi by dt plus 1 by L into pi. These are the three equations: force current analogy circuit or torque current analogy. Force equivalent is torque, torque equivalent is current. Then mass equivalent is J, J equivalent is capacitance in case of electrical system. Damper element is B, which is same as that of a rotational motion is B. In case of force current analogy circuit is the reciprocal of resistance. The reciprocal of resistance. And K in case of mechanical translatory system, that is equivalent is also K in case of mechanical rotational system. That equivalent analogy in case of electrical system is reciprocal of inductance. Then displacement X is equal to in mechanical translatory system, then angular displacement theta in mechanical rotational system, then flux pi in case of electrical system. These are the force current analogy circuit or torque current analogy circuits. This is analogy circuits, force current analogy circuit and torque analogy circuit. In case of force, the equivalent is torque, in case current. Mass equivalent inertia, that is equivalent to capacitance. Spring constant K equivalent to spring constant in case of mechanical rotational system and reciprocal of inductance in case of force current analogy circuit. And damper element B same as that of a mechanical rotational system B, and the one reciprocal of resistance is nothing but a conductance in case of electrical system, that is analogy circuit. Analogy element for damper element equal and analogy element in case of electrical system, that is equal to 1 by R in case of force current analogy circuit. The displacement X is equal to the displacement theta, flux is pi. Velocity is equal to dx by dt, omega is equal to d pi by dt, and d pi by d is equal to voltage. These are the force current analogy and torque current analogy circuit. These are the two analogy circuit in case of mechanical translatory with electrical system, mechanical rotational system with electrical system. This is the analogy circuits, force current and force torque analogy circuits. Then find out the transfer function in mechanical system. Same variables like that electrical system. Here x1 force and voltage is nothing but a variables. Then mass, spring constant and damper element are a elements to find out the transfer function of given force voltage and force current analogy circuit. Force voltage and force current analogy circuit. Half recording.